Okay, today we're going to start solving equations by using addition and subtraction. First thing we need to do is we need to decide, is there a difference between an expression and an equation? That is a resounding yes. There is a huge difference between the two. First of all, an expression would be more like a phrase in English. It's not full the full thing. Okay, so an expression can be a letter, it can be a variable, it can be a combination of the two, it can be addition, subtraction, multiplication, division, it can be lots of those put together, but it is not equal to something else. So an expression would be half of an equation, so 1/2. Okay, an equation is going to have the equal sign there. So this one's going to have an equal sign. This one will not have anything. The other difference is, what can you do with them? With an expression, you can simplify it by combining like terms, uh, doing the distributive property, things like that. You can also evaluate it. If you have variables in an expression, you can evaluate it given certain values for the variable. With an equation, you have a balance going on. You can simplify them, but then you can also solve. You cannot solve an expression. You can solve an equation. So let's talk about this then. An equation is a mathematical statement where two expressions are equal to each other. The solution to an equation is the value for the variable that makes the equation true. The way you need to do this is you need to isolate the variable. Now, what does that word isolate mean? It means get it by itself. So here's an example. This is a balance scale, and you can see that these two sides are equal to each other. One side has an x plus 3 on it. That's an expression. The other side has an 8 on it. That's an expression. Now, you can do pretty much whatever you want to an equation as long as you keep it balanced. So we're going to start today. What would be something that you could do to both sides of these equations, the exact same thing to both sides of these equations, to get the variable by itself? Well, the variable is right here and has a 3 added to it. So we're going to do what they call inverse operations, the opposite operation. What do we do to undo plus 3? We subtract 3. So if I subtract 3 from this side, this is now out of balance. But if I take it and subtract 3 over here, it's back in balance. And what we get at that point is these are gone, and we end up with an x and a 5, and that remains balanced. Okay? So we're going to do some of these. Now, what I like to do is I like to do these with a wall. And I basically say, okay, this is a wall right here where the equal sign is. You can't do anything through the wall. What you can do is decide what to do on one side of the wall and then jump over and do the exact same thing to the other. The side that you use to decide what to do is the side with the variable. So if I go over here to the left-hand side, I have x minus 5. To get rid of the minus 5, I add 5, which means I go on the other side of the wall and add 5 here. Make sure that these do what you want them to do. You want them to be the inverse of each other. You want them to cancel each other out. Okay? And I end up with x is equal to 12. Okay? Let's take our wall and move it over here. Again, look at the left-hand side so you can determine what you're going to do. This is p plus 3. So I need to subtract 3 from this side, which means I'll subtract 3 from this side. Those get rid of each other, and I end up with p is equal to 6. Okay? Now, we can do this with anything. Fractions, decimals, it doesn't make a bit of difference. All right, so let's take a look at this one. This time, the variable is over on the right-hand side. So I look on this side and say, what do I need to do to get rid of a plus 6/10? I would subtract 6/10, which means I have to subtract 6/10 from this side. That's gone. I end up with a b over here, an equal sign, and a 0.15. Okay? And let's try another one here. Okay, now we've got fractions, but again, it doesn't change the way we work it. I've got x minus 2/3. To get rid of minus 2/3, I'm going to add 2/3, which means I'm going to add 2/3 over here. In order to put these together, I have to get a common denominator. This is gone. Okay, so my common denominator here is going to be 6. This will be 3/6. This will be 4/6. So that's going to give me 7/6 is equal to x. Now, the neat thing about solving equations is that you should never walk away wondering if you're right or not. To see if you're right, all you have to do is substitute in. So in this one, I said that x was equal to 12. Very quickly, I go 12 minus 5 equals 7. Check. I said P was equal to 6. 6 plus 3 equals 9. Check. Here I said B is equal to 0.15. 0.75 is equal to 0.15 plus 0.6. Check. All right, here I said that x was equal to 7/6. So I have 1/2 is equal to 7/6 minus 2/3. That's 7/6 minus 4/6, which gives me 3/6 is equal to 1/2. Check. And that's it.